Hi there, this is David from DTU, the Technical University of Denmark. Welcome back to these sessions. In this session, I'm going to be talking about R. So the session is about R software. It's a statistical software, and you will learn to use how to use it. For instance, the basics of how to load data into your session, how to get help, and how to obtain packages to work with R. So the learning objectives are you will be able to load data in R. You will be able to install and use packages in R. And you will learn that R is an object-oriented programming language. And what is this plan of this lecture? How is this structure? We will see that why R is a cool tool for AMR analysis, and you will see how to start use R and how to download RStudio, which is a companion software for R, which makes it very easy to work with R. And we will see how examples of how to load data and how to load packages and how to obtain help. So why you should use R? Well, R for antimicrobial resistant analysis. The first thing you should know that the R is a free software. You can go to this web address and you will get R, which is for free. And the second part is that it doesn't matter what kind of computer you have. You might have a Linux, a Windows, or a Mac, and then you can use it. So it's quite versatile. So it's open source. That means that a lot of development is happening because many people can contribute because the software is open. The structure, how it is made, is open to everyone. And the learning resources are freely available on the web. So you use a search engine for a particular topic, and then you will get quite a lot of information. You can get books, videos, so a lot of information. Allows to do a lot of varieties of statistical procedures. So it's quite powerful in that sense, and also the graphic capabilities are quite nice. They're very good for graphics. So that's something that you might want to explore by using R. And the popularity is also growing. Have a look at this website to learn about the popularity about R. So if you go to this web address, this is what you will get. Just get ready to download R in the platform or in the computer you have. When you download R, that is what you will get. Then you will get screen, and you see the prompt that is waiting for you to write something. And so that's why we will use RStudio. So also RStudio is freely available. You just have to install it, and we will facilitate our work when we are using R. About these slides. So in these slides, you will see a gray box here, and it means that this is the code, something that I am writing in R, and I'm writing here 3 + 4. And this is just summing. And you can use this hashed symbol, and this is just to make a comment. So I will not use this comment that you are using here. It's just to remember what you have or what you are doing. As I said, R is an object-oriented language. It means that you create objects in your environment. And this, for instance, we have created 2 objects, an object A and an object B. And you create these objects by giving them with this equal sign or with this arrow. So you say A is equal to 3, and B is equal to 4. And so if you want to see what is A, you just type A and it gives you the value of A, which is. So this is how you can just start using R by making some maths. And then with this function called ls, you can get what is what are the objects that you just have created in your environment, which is A and B. And you can also, as I say, zooming with this object you just created. So this is multiplying or exponentiating. Have a look at that. So there are quite a number of packages. Packages are different tools, and here we have the definition, which is a collection of functions developed by the community. As I mentioned, it's an open source software, so many people is contributing, making different tools for different purposes. So there are about thousands of packages, and they are contained, or they can be found on these repositories. CRAN is the official repository of R, but you can also find some packages in Bioconductor or in GitHub. So how did you install a package? You install it with this function, install packages, and then within this quotation you write the name of the package you are interested in using. In this case, let's say we are interested in epidemiological tools, and this package is called EpiR, and we can install it by typing this, and we will install EpiR in our computer. Once it's installed, then you have to tell R that you want to use that package in your session, and you do it with this function called library. Here's an example that we want to use a package called AMR, antimicrobial resistance package, and we will use it with this function. Please note that when I use library, I don't use the quotations, which is different from install packages. You will need the quotations here. You can also install packages from R menu. On the bottom right pane, you can install it. There's an option to install, and then the repository CRAN, and then you will just write the name AMR and then install, and that's it. You might need to update your packages, and the way to do it is by telling you first which are the old packages you have, and you write this function, and you will get the packages that are old and that they need to be updated. You want to update them, then you say update packages, and it will update all your packages. You might want to check which packages you have installed, and you will use this function, and it will provide you the packages you want. If you want to install, if you want to update just one particular package and not all of them, you just have to reinstall the package by, say, install package, and that will, in that way, you will get your updated package. Another important feature is how to obtain help, and you will get help by using this function. Let's say we want to know about this function called min. So the way to do it is by typing this min, help, and in the brackets, within the brackets min. If you want a more generic information about a topic, then you will need these two quotation marks and then the name of the topic that you are interested to know more about within R. So I have a quiz for you now that you already know how to install package. Let's say you want to install, let's say if you have installed Tidyverse on your computer, how would you do that? Would you just saw it in 2 slides ago? Is it updated? How would you find out whether it's updated? Think for a moment and see if you can solve it, or go back in the video and see if you can give me an answer. Okay, so if it is not installed, well, you have to install it. So the answer for this quiz is that with these installed packages, will let you know which packages you have. So if Tidyverse is installed, it will give you a name that is already there, and you can see whether Tidyverse is updated or not by typing this. So if it's not installed, then you have to install it like this, install packages. So loading and importing data in R, very important. So data very often comes in this format, is comma separated value or table separated value, or you probably have your data in Excel or in a statistical software. Somebody sends you their files in SPSS format or Stata or SAS. Doesn't matter. In R, you can import that data in your environment. So for comma separated values, this is the way to do it with read dot comma separated values, and you can find out this comma separated value data set here. So you can try, and please note that we are giving a name to this data set. We are calling this data set dat, and so this is an object that we are creating. So when we check what is in our environment, we will see that we already have these three objects into our R session. And what kind of object is that? And we will see that is a data frame, is a data set for R. The other way to do it is by using this function called read underscore comma separated value. And we will do the same. You will need this package, read R, and we are going to give it another name. Let's say datos. Let's say that your data is not on the web, but is on your computer. So if it's a Windows machine, perhaps it's in your hard drive called C, and it's in your desktop, and in a folder called data, and the data set is called this. So you have to give the name of the data set and the exact location. Please notice these forward slashes that I use. It's very important. They are forward. The backwards will not work. So you just have to make sure that they are in this direction. And we are giving to this data set this name. And so if we can check whether our data is already there by typing the name, and it will appear. Or you can also use this function called view, and it will show you the data set we just loaded. You can also use this head function, and will give you the first 6 rows of your data set. So you can also use the right dot pane to import your data, and here you have the options to do it. And so you don't have to write. Perhaps it's easier just to click and browse where your data set is, and then that's it. Then you have your data set on your computer. And notice that RStudio will give you what has been written to obtain the data set. So another important thing you need to know is about how you save your work. So we have already in our environment 4 elements for objects, and we want to keep them for the next session, so we don't have to repeat everything we have done so far. So we use this function called save image, and we tell where we want to keep it, and then and we give it a name, intro, and with this R data. So this determination of R data is telling R that this is how we want to save our environment. And you can also use, of course, RStudio by selecting here on the right hook pane that you want to save your environment. With your environment, there is a disk save, and then this is how you do it with using clicks. You might also want to save what you have written. So you have this is what we have written. C equal to 4, D is equal to 3. And then we have written this to obtain our data set. So we don't want to type that again. So we will just save it. And the way to do it is by selecting this disks in this top left pane of my RStudio session. So what we learned today, we learned about the R is a cool software, it's free software. The documentation is quite abundant. You can use it in almost any kind of computer you might have. We learn how these objects we made in R, A, B, and the data sets. We give them a name, and that's how R is working. Creates objects, and then you can do things with those objects. And we learn also about how to load packages, import your data, get help, and serve your work. So here is how you install packages, code, bring that package in your session, how you read your data, how you get help, and how to save your environment. So we have some exercises and quizzes